at this point, we're going to move away from proving identities ourselves, and we're going to actually just start using identities, kind of like formulas. So we have 3 of them here that help us to figure out the sine, cosine, or tangent of a sum or difference of angles. So let's just take a quick look at the formulas and see what they're saying. I think of this as 2 different places, first and second, not necessarily x and y, it's just a placeholder. So sine of x plus y, I use the plus up here, would be sine of x, which is sine of first, cosine of second, plus, take the top one, cosine of first, sine of second. That's how I'd look at that formula. Or if I'm doing the minus, I'd use a minus here for subtraction, and I'd just use the minus down there. Cosine's the same thing, first place, second place. So if I'm doing cosine of x plus y, it'll be cosine of first, cosine of second, minus, be careful with that, make sure you use the right one, sine of first, sine of second. So just be really careful when you look at the values. Tangent gets a little trickier. For example, if I'm doing tangent of x minus y, a difference, then I'd have to use minus on top and plus on the bottom. And just notice how it's first value, second value, first value, second value. So you just have to be careful when you're looking at the formulas and choosing which one to use and how to use it. So let's use some of these things. The question is, why do I need them? I need them because of this word right here, exact. Exact to us means I want some sort of special triangle. So 30, 60, 90, or 45, 45, 90. That's what I'm thinking. And if I look here at my problem, 75 degrees is none of those. So maybe if I can write it in terms of special triangles, I can get a lot out of this. So instead of thinking of it as the sine of 75, I'm going to think of it as the sine of 30 degrees plus 45 degrees, because 30 plus 45 gives me 75. So I come up here and I have this in the right format. I have sine of x plus y. So I'm going to be using the plus here, and I'm going to be using the plus there. So this is sine of first, cosine of second, cosine of first, sine of second. So let's write that out. It's going to be sine of first, so sine of 30, cosine of second, 45, plus, because it was the top, cosine of first, which is 30, sine of second, which is 45. And if you look here, now I have everything in terms of special triangles. I can go through and use my 2 special triangles that I have listed over here and just figure out all of these values. For example, the sine of 30 degrees, just go back over here. If you remember, sine of 30 is opposite over hypotenuse, so that's going to be a 1/2. Cosine of 45, once I rationalize, is root 2 over 2, plus cosine of 30 is going to be adjacent over hypotenuse, so root 3 over 2, times sine of 45 is also root 2 over 2. And at this point, it's just all arithmetic. So let me scroll down a little bit. I go ahead and simplify. I get root 2 over 4 plus root 6 over 4. Combine like terms, because they have a common denominator, I get root 2 plus root 6 all over 4. So the sine of 75 degrees, sine of 75, equals exactly root 2 plus root 6 over 4. If you were to take sine of 75 in your calculator and get the decimal, and take root 2 plus root 6 over 4 and get a decimal, they'd be exactly the same thing. So that's why we use these sum and difference identities. Second example, if we look at a cosine example, cosine of 15 degrees, since we want exact, I'd be hoping 15 is a special angle, but it's not. So I have to make it special angles. So I'm going to make it the cosine of, let's see, 15 could be written as 45 degrees minus 30 degrees. So I come up here and I see cosine of minus, which means that I'm going to be using plus right there. So I go ahead and rewrite it. It's going to be cosine of first, which is 45, and then cosine of second, which is 30. Notice how I don't make it negative 30, because the negative sign just means use this sign right there. So cosine cosine plus sine of first, which is 45, and then sine of second, which is 30. And again, I come over here to my special triangles and just get all these values off. Cosine of 45 is root 2 over 2. Cosine of 30 is going to be root 3 over 2. Plus sine of 45, root 2 over 2. Sine of 30, which is 1/2. So I'm actually going to end up with root 6 plus root 2. It's all over 4 because both of my fractions were over 4. And this is going to be the value for cosine of 15 degrees. Notice that's the exact value, which I believe is exactly what we just had for my other sine value, which makes sense because 15 degrees and 75 degrees are going to be coterminal angles. Not coterminal. They're going to be complementary angles. There we go. That's the right word. So my final value is root 6 plus root 2 over 4. For right now, I'm going to stop there. The second video is going to go through and explain how to do a tangent example because there's a little more algebra. And we're going to also look at how do I work backwards and do some more complicated problems with this.